Let's continue looking into SmallRye fault tolerance. As we already discussed, this is a really helpful tool to make your service more reliable. And let's now have a look at the fallback annotation.
Okay.
So yeah, we have our unreliable cookie service. We added now some retries, so this makes it much better. Let's cut down a bit on these here, just for the sake of demonstration. Still, we might have the issue that when we have a very unreliable service, that we run out of fallbacks. So I'm calling this now again. Oh, now it worked. I'm too lucky. Okay.
Okay.
Just to show the result, we are out of ingredients. We already saw it here in the log.
Yeah. Wait. Maybe you want to shortly go back to the bake cookie part. For those who just started.
Okay.
Just to.
Yeah. So we have our bake cookie implementation here, which is a bit unreliable because in 20% of the cases we might run out of ingredients, and in 80% of the cases we burn the cookies. We have a very unreliable cook at the moment, or baker. And if all goes well, we return the new cookie. And to improve the situation a bit, we added the retry. We now retried 3 times with a delay of a second. But we only do this in the case the cookies are burned, because if we have no ingredients left, then yeah, no need to retry. We have no ingredients left, so that's why we exclude this this exception here. Now, in the case the baking of cookies fails, we still want to do something for our customer. So we can add a fallback. It's another one of the SmallRye fault tolerance annotations. You can just add this fallback method, and then there is it's fallback annotation, and then you specify a fallback method. Here you have to specify the name as a string, which is a bit not so nice, but it's based on how annotations work. Let's call it bake cookie fallback. Very creative name. At least it's speaking. And we have this method here.
Fun with bake cookie fallback.
Yeah. It's always fun with Kotlin. And in that case, we maybe here is an old cookie. So if we fail to bake a new cookie, then we just get an old cookie from storage and hand you the old cookie.
Okay.
I mean, it's better than no cookie. So
or a burnt cookie.
Yeah, or a burnt cookie. So so that's what we will do now. And I will just let me add a logging here. So cookie, and I will call this, and let's see how lucky we are. So again, it has to first go through the retries. Yeah, first rebuild, because I changed the code again, but then it goes through the retries, and the rebuild once. Okay, yeah. The first try, and then 3 times retrying it, so actually it does it 4 times. And we still burned the last one, so we are falling back to the old cookie, and here's an old cookie.
Okay. Which takes a lot longer. But yeah.
Yeah, I mean, it takes until we give up. It takes time. because we retry with a second of delay. And I mean, now you could say, okay, let's reduce the delay, which has the risk that you DDoS the other service, but it goes quicker. And it also has the risk that the situation might not have improved in that time. The longer you wait, the more chance you have that the other service has recovered.
Okay.
Or maybe it crashed and needs a bit of time to reboot. If we have this 1 second delay, then you have like 4 seconds for it to reboot, which should actually be enough.
Okay.
Yeah. So that's the retry annotation.
Okay, but basically this would this fallback. Yeah. So basically this chapter would only be the fallback.
Yeah.
So you don't have retries. So this means if you go into the first one, which means no ingredients, you get an old cookie back.
Yeah.
And if you get into the second one, where you burned it, you will also get an old cookie back.
Yeah.
And if you get all the way to the end, you would get a new cookie and you wouldn't hit the fallback, right?
Yes.
Okay.
Let's increase our chances. Here's a new cookie.
Nice.
Here's an old cookie. New cookie. New cookie. Huh? Old cookie. But if we would not have the retry at all, I mean, you can also do that. Just get rid of that. Then we get the old cookie way more often because we just don't have the retry.
Yeah.
And again, you can do this basically everywhere. You could also do it here on the resource and then return a default response or so.
Okay.
You can do it way down the line in some internal service and return a useful fallback. For example, if you have like a recommendation system. And maybe it's just down at the moment, but then you could hard configure some default recommendations, like the most sold products or so.
Okay.
I mean, it's better than showing an error or showing nothing.
Right, yeah.
So you could say, hey, if it really doesn't work, just return the default recommendations. And again, it depends on your use case. One thing I want to add is there's not only this fallback method, there's actually also a fallback class that you can specify. And this class needs to implement this fallback handler interface. And there you get this execution context, which contains method, parameters, and the failure, so the exception. And then you could even, based on which type of exception you had, you could return a different fallback or so.
Okay.
Yeah. So yeah, this is more flexible and also better typed. But for the quick and dirty solution, this also works. And I mean, if you have an IDE like IntelliJ, you can still rename, and it doesn't work. Yeah, normally you can, but that's the risk. However, we have Quarkus. So this is, although this is just a string here, it's not like this is reflection that is running during runtime. This is actually connected together during compile time. So now we have or during startup, it notices this already because it connects it all together and notice that this one here is not connected. Yeah, so on the bake cookie, we can't find a fallback method.
Oh, okay.
So you have a check there.
Nice.
Okay. I think that's it about the fallback.
Okay. Let's recap.
Yeah. Fallback is a nice annotation where you can implement a fallback. If your method fails, you can do it after you retry it a couple of times or in any other failure. Just provide a default response that could handle things more gracefully. instead of throwing an arrow. Yeah, and that can be really helpful.
Nice. I wasn't looking, but is the status, the HTTP status code for the response also changing, or is it just as a normal, all done, all good response when you do the fallback?
It's then an all good response.
Okay.
At least in how we used it, because we just from our service returned a response, and our response object was only a string. So the string got returned and the caller got a string. So for him, it's all fine.
Yeah, but normally you would do the same thing, right?
Yeah.
The fallback is actually an acceptable answer in a successful state, but you couldn't get it. That's why it's a fallback.
Yeah.
Okay.
But you could also, when you use it, for example, on the REST method, on the resource method, then you could also return a different response and set a different status code on the response. Maybe you have talked with your client and told them, hey, in case it's a fallback, they want to show a bit of a different UI with some different content, then you could send them a different status code or so.
Interesting. Okay. Nice.
So you're flexible there, but if you do it like super down the line in a service, then you probably, you would need to extend your response object to include that information. But again, like you said, a fallback should be an answer that is also good. It might not be the best answer, but at least a good one.
Yeah. Who wants an old cookie?
Better than no cookie.
Right.